We're going to continue our notes on fundamental theorem, and we are looking at example 8. So pictured below is the graph of f, and find the values of each of the following definite integrals. If a value does not exist, explain why. So we are looking at this picture, and we're going to have to find this by some algebra, by some geometric formula. So the first thing I do is I go to my graph and I try to figure out what pictures I have. This says I got to go from -4 all the way to 2, which looks like I have a bunch of different shapes here. It looks like I have a trapezoid in here, and then I have a triangle and another triangle. So I'm going to apply all of those formulas. Remember, I'm using the graph. So I'm going to kind of color code it here. So I'm going to do the blue first, and the blue is going to be my trapezoid. So I know trapezoids I divide by 2. I need to find 2 bases and a height. So my bases are actually this leg and this one here. So it looks like one of my bases is -4 and one of my bases is -2. And then my height is this distance in between, 1, 2, 3. I'm going to add that to the next thing. The next thing is this little skinny triangle right here. I know triangles I divide by 2 as well. It looks like my height is -2 and my base is 1. And then finally we have this little triangle here. So it looks like on that one, my height, I'm divided by 2. My height is 2 and my base is also 2. So let's go ahead and add those together. So we end up with, let's see, -6 times 3/2. These guys would cancel and I would just get -1. I could cancel one of those. That would give us 2. 2 goes into 6 3 times, so that would be -9 plus 1, which is -8. I just realized I messed that up. I have a typo, sorry, because I was looking at my answers really quick. I put a -4. It should have been a -3. I counted the wrong way. So this is going to be a -3. Let's fix it. It was -3 minus 2. So let me totally fix that. And so that's going to make this is going to actually then be -5, which is not going to cancel. So these are not quite as pretty as we thought. It's going to be -15 halves, and this was just going to be a 1. So another way to write 1 is 2 halves, so this would be -13 halves, and now that's fixed. All right, let's take a look at the next one. I'm going to erase my picture. So I am going from 0 to 3 this time. So 0 to 3. So I'm going to do this triangle and then the little skinny triangle. So I'm dividing by 2. My base is 2. My height is 2. And then this little triangle here is going to be, again, I divide by 2. My height is -2 and my base is 1. So it doesn't look like I really want to cancel this actually. So I have 4/2 minus, oh, I can cancel 2/2. That's not too bad. So I end up with 2 minus 1, which is going to be 1. All right, let's take a look at the next one here. We're going to go from -1 to 1. Okay, we're going to see a property about this here in a little bit. So I'm going to divide both of them by 2. I know that we have a height of -2 and a base of 1 for that triangle. So that's the purple triangle. And then the green triangle is going to be a height of 2 and a base of 1. So it looks like we have -1 plus 1, because the 2's are all going to cancel, which ends up equaling 0. So you notice how one was positive, one was negative. They ended up zeroing out their areas. All right, let's try another one here. So we've got f prime. This is a little bit different because notice all the rest of them was f. All right, so we were talking about D here. So notice I would have to look at where this is. So I'm going to go from -4 all the way to 0. And what's happening is, remember, we're looking at the slopes here, because when I go to integrate that, I'm looking at f. okay? And they told us this was the graph of f below. The problem is technically if I am, when I integrate this, because of this corner right here, I don't have that derivative that exists at that corner. It's not continuous. So therefore it doesn't exist and it's not differentiable at 1. So that's what we're going to say is this one does not exist because f prime is not continuous at x equals -1. So as f of x is not differentiable there. Okay, let's take a look at -1 to 1. Let me show you the difference in the next one here. So now the next one is saying, hey, you get to go from -1 to 1. So it's kind of the same setup, -1 to 1. Do you see how there's no corner in the middle of the interval? That's why we're allowed to use that one. So we know when we integrate, it's a little bit different than finding the area of the shape. So when we integrate f, f prime, we get back to f. We're going to evaluate that from -1 to 1. So we've got f of 1 minus f of -1. So we're going to read those values off the graph. F of 1 looks like it's 2. And then f of -1 is -2. So double negative is going to go positive, so that's 4. And then finally, we have from 1 to 3. So let's double check that we have the derivative in that interval. And let's see, it said 1 to 3. So 1 to 3. Again, I don't have any corners in there, so we're okay. All right, so let's try. When we integrate f prime, we know we get back to f. And then we're going to go from 1 to 3. So we do f of 3 minus f of 1. So I'm reading the y values off the graph. F of 3 is -2, whereas f of 1 is 2. So we're going to have -2 minus 2, which is going to be -4.